Let's talk about how to find the 4 facts about a subnet when you've got a nice, easy mask, specifically a /16 or a /24 mask. So by easy mask, I mean any mask that happens to have only 255s and 0 in the dotted decimal mask, and there they are on the screen, 3 of them. And it turns out of those, only the /16 and /24, the 255.255.00 and the 255.255.255.0, the bottom 2 rows, only those actually cause subnetting to happen. So those are the only 2 we care about. Now, why just pick on those 2 masks? Well, it's a learning process. So for those of you learning this for the first time, we will use only the easy cases for this lesson and the next. And then once you get good at that, then the next 2 lessons will take all the rest of the masks under consideration, and you'll extend the process and get better, adding just one more variable in, if you will. So that's the only reason we separate out and look at these easy masks. So let's look at an example. Here we have a network, and we have some LANs on the right at branch offices maybe, and each branch office has a LAN that has one subnet, one VLAN and one subnet needed, and there they are. And they all happen to use a nice easy mask. So if I were to say to you, find the subnet ID, subnet broadcast address, and range of addresses, you might look at that and say, well, okay, shouldn't be too hard, but you may not know how. Let's talk about how specifically. So first off, that upper right-hand subnet, those are the 4 facts at the top. Subnet ID, first, last address, and subnet broadcast address, and we have a process to find it. Here's a table with the same answer for the other 5, and look at those and notice the pattern. Notice all the subnet IDs in this case happen to end in 0, and all the subnet broadcast addresses in this case all end in 255. The first and last addresses all end in 1 and 254 respectively. And yeah, that's a pattern in the easiest cases, and we will see that as you do more and more samples. But let's learn the process. Here's the process, and I'm not going to read it to you. We are going to practice it so you can do it. That's the end goal. So you don't need to memorize Wendell's specific words, but I do want you to practice well enough so you can do the math. So the highlights, we're going to set up the problem on paper. Then we're going to think about the problem as 4 octets, 4 columns. Columns in which the mask is 255 and the columns in which the mask is 0, and then one last step at the end to tack on. So let's take a look at how this works. First off, setting up the problem is actually important. So at step 1, I want you to have dots, and you're going to have a place to write the mask and address, and then space to write 4 more dotted decimal numbers. So what's going to go in the bottom are 6 total dotted decimal numbers, but you want column alignment. You don't want it to be all over the place. Just like when you worked algebra problems growing up, your teacher might say, be neat. You know, you don't want to put the ones digits over the next, below the hundreds digits when you're doing addition and multiplication, for instance. Just line up the problem, and you want enough width to write 3-digit numbers in each column, because dotted decimal numbers go from 0 to 255. Next, we're going to work column by column. And this is a generic view of the process. Then we're going to show a bunch of specific examples. But in any octets for which the mask is 255, we have some steps to take. So in this particular case in the bottom, we've got 3 octets of 255. So in all 3 of those octets, we're going to do the tasks listed at the top. By the way, at the top, 2, A and B are copied directly out of the big long eye chart of everything you need to do for the process. So we copy the addresses octets to the subnet ID, and we copy the addresses octets to the subnet broadcast address. So those equal signs just mean we copied the address. At step 3, we key on octets that have a mask value of 0. In the bottom case, it's only 1 octet with the mask of 0. So in that case, we write a 0 down for the subnet ID and a 255 for the subnet broadcast address. And then finally, to find the first and last addresses, you add 1 to the 4th octet of the subnet ID. So this action happens only in the 4th octet. And to find the last address, you subtract 1 from the broadcast address. So that's kind of a generic visual view of the process besides the words. There's a reminder of the process in words, and now it's time to take a look at some examples and bring this into focus.